If you get a simple paper cut, you probably won't even think about it by tomorrow. But right now, at a microscopic level, skin cells are dividing and migrating, zipping that wound closed to reconstruct the barrier with the outside world. Every single day, your body replaces roughly 330 billion cells. It constantly repairs broken DNA, rebuilds damaged tissue, and maintains 30 trillion internal cells. Which raises a very strange question. If human biology holds a precise blueprint for perfect continuous self-repair, why do we age? Why does this system eventually lose its ability to fix itself? To find the answer, we have to look past the individual cells and look at the logic that governs them. The breakdown of these repair systems may not be a random failure of biology, but a consequence of its most basic rules. We often assume the goal of natural selection is to help the individual organism live as long as possible. In reality, evolution does not focus on your personal longevity. Evolution prioritizes the transmission of your genetic blueprint. Think of the physical body as a temporary vessel and the genes as the passengers. Nature's primary concern is ensuring the passengers reach the next generation. To protect that genetic code across millions of years, biology makes a specific trade-off in how it spends its limited supply of energy. In the wild, every living creature operates on a strict, finite budget of energy. Since calories from the environment are limited, biology forces a decision on how to distribute those resources. This energy is split between two main tasks. First, there is somatic maintenance, the energy used to repair cells and keep the body running. Second, there is reproduction, the energy used to grow and produce offspring. Because the natural world is filled with predators and accidents, most wild animals will never live long enough to die of old age. For a species to survive, it makes more sense to spend energy on reproducing quickly rather than trying to maintain a body that will likely be killed by an outside force anyway. This is known as the disposable soma theory. Nature invests in the next generation and allows the original body to degrade because, in the wild, long-term survival is statistically unlikely. This energy trade-off is hardwired into our DNA. Evolution favors genes that provide a benefit early in life, even if those same genes cause problems later on. On this timeline, a gene might create a youthful peak in strength or fertility, giving an organism a massive reproductive advantage. But that same genetic trait can be the very thing that triggers an exponentially rising risk for disease as the body gets older. This is antagonistic pleiotropy. It's a biological compromise where we pay for the vigor of our youth with the eventual breakdown of our old age. Once an organism has successfully passed its genes to the next generation, it effectively falls out of the reach of natural selection. Because our ancestors reproduced in their youth, evolution had no way to weed out the mutations that cause cancer or organ failure at age 80. By then, the genetic cargo has already been delivered. We deteriorate because there is no evolutionary pressure to maintain a body that has already finished its primary biological task. While individual death feels like a failure, it is part of a larger, unbroken success. Life has continued for billions of years precisely because it moves in cycles. By rotating through generations, species can mix their genes and adapt to changing environments. This turnover allowed life to evolve from simple cells into the diversity of the modern world. In this context, the human body functions as a temporary vessel. It exists to carry a single, unbroken genetic chain across time before fading into the background. Death is the price paid for a world of complex, adaptable life. It is the mechanism that allows the whole to survive, even as individual parts are replaced. If the earliest organisms had never died, they never would have needed to change. Evolution would have stalled at its basic level, and the human story never would have begun. Our mortality is not a flaw in the system. It is the engine that keeps life itself alive, continuously driving existence forward.